All right, guys, this video is going to go through all of the highlights of Unit 4, Topic 1, which was all about probability. So we started out with this number line, talking about the probability that it will rain. And we talked about a couple of different pieces with this. So first, we practiced our fraction decimal conversions. So the 70% would go with the 0.7, 10% down here with the 0.1 or 1/10, the 50% at 5/10, and the 60% at 6/10 or 0.6. And then we also talked about vocabulary that we associate with probability. So there's no chance that it will rain would have to go here at the 0. If we're off of the 0, even if it's a really small chance, there's still a chance that it might rain. It will definitely rain would be down here at the other end at the 1.0 or the 100%. Equally likely to rain or not rain means there's the same chance that it would rain as that it wouldn't. And so that would go here at the 0.5 or the 50%. And the chance that it will rain is 1 in 4 would be 25%, because a 1 in 4 chance would be the fraction 1/4, which is equal to 25 over 100. And 25 out of 100 is 25%. So I'll try to keep referring to this vocabulary as we go through some other examples. But we also talked about a couple of other words. If we're up here on this end of our number line, these are all events that would be likely to happen. And then if I'm down at the other end of my number line, so this area, so higher than 0, but less than 50%, I would call this unlikely to happen. And this does not seem to want to write. There we go. Unlikely to happen. So if we are looking at this situation, and we did this in class, we have 20 animal crackers. So a sample of a big jar of animal crackers. And this table shows the fraction or the part of the 20 that each animal is. So you have lion 2, camel 1, etc. And we wanted to determine the probability as a fraction, a decimal, and a percent of selecting each kind of animal cracker. So selecting an elephant, I can read that right from the table. There are 5 elephants out of 20 crackers. And if you need a refresher, in my calculator, because you can use calculators for this assessment.
Good afternoon, students and sponsors. The time is now 3:10 p.m. At this time, all students should be in their designated after-school activity. Sponsors, please escort your students to the cafeteria to receive their afternoon snack. As well, you can bring your attendance sheets for your clubs. Thank you.
All right, sorry guys. So if I'm using my calculator, I just do my numerator divided by my denominator. So 5 divided by 20 will give me the decimal 0.25, which is 25%, because remember, to go from a decimal to a percent, I multiply that decimal by 100. If I'm looking up at the table, the probability of getting a camel, again, this is right in the table. I can see that there's 1 camel out of 20. I do that same math again, but this time I get 0.05 or 5%. After this, the wording gets a little bit different, and it's really important to talk about these different examples. So the first one was not a monkey. So this means reaching into our sample of animal crackers and getting anything other than a monkey. So if I look at the table, there are 4 monkeys. There are 20 crackers. So that means there are 16 left that are not monkeys. So 16 out of 20, not a monkey. That is 0.8 or 80%. So a penguin or a zebra means that this penguin, this 3 out of 20 would be fine. And for a zebra, it's also 3 out of 20. So it's reaching into the bag and getting either a penguin, or a zebra. There are 3 of each, which means there are 6 altogether. I have a 6 out of 20, or 3/10, or 30% chance of getting penguin or a zebra. Finally, on this practice, we were talking about a rabbit. And if I look at the table, there aren't any rabbits. And if there aren't any rabbits, then there's 0. There is no chance of getting one. It would be 0 across the board. We also talked about a couple of other vocabulary terms other than likelihood of things happening. We talked about the difference between experimental and theoretical probability. So theoretical is what we think is going to happen, what should happen. And then experimental or empirical, those are the same meaning, those 2 words, is what happens when we actually conduct an experiment. It might be the same as our theoretical, or it might be completely different. So we talked about this Wheel of Fortune example. This one was one of our formatives for this unit. If this wheel has 24 sections, and I look around and I see that there are 1, 2, 3, 4 places on that wheel that say $200, then the probability of spinning 200 would be a 4 out of 24. So this translates to about a 17% chance. So it is unlikely that we would spin the wheel and land on $200. So similarly, bankrupt or lose a turn, there is 1 bankrupt right here and 1 lose a turn here. So there's a 2 out of 24 chance of spinning one of those 2 sections. So that's less likely to happen. That's only about an 8% chance, but it's still possible, even though it's unlikely. Let's go down to, actually, let's go to the next page. We did this one as a stations activity. So all of you saw this, regardless of, this was an activity where you, everyone did station 1, and then how you did on the dictated where you went for 2 or 3. This was one where we had a table, and that table had fractions, decimals, and percents.
Joshua Crawford, if you're in the building, please report to the main office. Joshua Crawford, report to the main office.
So this table has the number of servings of fruits and vegetables that Ricky is likely to eat on any given day. So if we just randomly pick a day, this table says there's an 8% chance that he had 0 fruits and vegetables, a 0.13% chance that he had a serving, a 7 out of 25 chance that he had 2 servings, 39% for 3, and 12 out of 100 for 4. Now for me, as soon as I see that there's different representations of numbers in my table, I try to fix that. And I'm going to change these all to percents. You could change them all to decimals, and if you were really ambitious, you could change them all to fractions, except then you need to work with a common denominator. So this 0.13, I would write as 13%. The 7 over 25 is 28%. As a decimal, it would be 0.28. And then 12 over 100, it's already out of 100, that's 12%. This first question says, what is the probability that on a given day, Ricky eats 2 servings of fruits and vegetables? That is right at the front, or right in your table. So 2 servings of fruits and vegetables, right here, 28%. The next question is a little bit less straightforward. So it talks about the probability that he eats more than 2 servings of fruits and vegetables. If I look at my table, more than 2 could be 3, and it also could be 4. So it's saying what's the probability that on any given day it's one of these 2. Well, on day, or for 3 servings of fruits and vegetables, it's 39%, and then for 4, it's 12. So in order to figure this one out, I would just say 39% plus 12%. And when I add those together, there's a 51% chance that we would choose 3 or 4 servings. So similarly, this last question says at least 2. At least includes 2. It's a minimum of 2. Like if I say you have to be at least 16 years old to get your license, you can't be less than 16, but you could be 16, 17, 18, and older. So it includes 2. So that means I was already at 51% for that 3 servings or 4. And to that, I'm going to add the 28%. Which means that there's a 79% chance of choosing 2 servings, 3 servings, or 4 servings. So pay very close attention to the vocabulary when we are talking about only certain sections of a table on a probability question. The other thing that we did with probability was we made predictions. And these predictions may or may not be true, but the point is you have to be able to look at these as equivalent ratios, proportions, equivalent fractions, whatever word you use to associate with fractions that are equal to each other, that's what we're talking about. So in this particular situation, you're looking at a fun-sized bag of M&Ms versus a medium-sized bag of M&Ms. And we can make a mathematical prediction as to how many, let's say, red M&Ms should be in the bigger bag based on what's in the smaller bag. Now, it may or may not be true. It doesn't have to work out that way. It could be that you open up the big bag and there's just as many red M&Ms as in the little bag, and that would be perfectly fine. But what we should be able to say is, if we're looking at this fun-size bag, there's 4 red, 7 brown, 3 blue, 2 green, and 4 yellow. And if I add those all together, that makes 20 M&Ms in the small bag. That means there's a 4 out of 20 chance that one of them would be red. It says in the medium-sized bag there's 180 M&Ms. So when I do probability now, it won't be out of 20, it'll be out of 180. So in every group of 20, I can expect 4 red ones. So I need to say, well, how many groups of 20 are in 180? And if I can do that in my head, I notice that 20 times 9 is 180. If I can't do that in my head, then I work backwards. I say 180 divided by 20 is 9. Which means that there's this times 9 relationship going the other way. If these are equivalent fractions and I've multiplied my denominator by 9 to get from one to the other, then I absolutely have to do the same thing to my numerator. And 4 times 9 is 36, which means I could predict, or I could expect, that there would be 36 red M&Ms in the larger bag. That same times 9 relationship would be true for brown and blue and even green and yellow that aren't in the chart. But if I did that same math, I would say 7 times 9 is 63. And 3 times 9 is 27. So that's how many brown and blue M&Ms I could expect in the medium-sized bag. I am going to have to add a second video to talk about what we have left, which is tree diagrams and conducting a simulation. So that will be added secondly to our classroom for you to watch before the test.